Ooh, now here's a nice question. Question 11 from the October-November paper 2022, paper 1. And we've got a circle, the equation's given to us here. Let's get a pen ready over here. So the equation of the circle is given, which means we know a few things. We know its radius, we know its center is definitely over there. The radius there, if we drew it to the tangent, we know this point here, D, effectively is quite easy as well because, it's just going to be the x value is the radius, 0. Okay, C, well, there's a tangent, and we know the tangent and the radius form a special angle. Well, yep, I'll put it in, so there's 90 degrees. So that's hiding over there. If we've got this radius, which we do, we could maybe add this distance, we could work out this distance. There's Pythagoras maybe coming in. And notice that what I'm purposely trying to do is, I'm not looking through the question yet, particularly because we got time. We're not looking, what do we do exactly when they're in the exam? But we just have a few ideas floating in the back of our mind of what's happening with circles and straight lines and tangents and radii. Okay, but let's see what we're told. We're told the equation, we're told the tangents touch at B and C, which means also we've got some lovely symmetry going on here. We've got this is a radius, that's a radius. Those are the same. We've got a 90, we've got a kite. We've got a cyclic quadrilateral hiding there as it so happens as well, and all sorts of things here, right? So which of these are we going to need? And we've got A10, 0, 10. Now these tangents, of course, there's another concept here, and that is if you've got a circle and a straight line, and that straight line is a tangent, it only touches the circle once. So if we had another situation like this over here, not a tangent, touches the circle at 2 places. And if we had another one over here, not a tangent, oh, that's a very cool little color, isn't it? But maybe we should go for that. These lines over here are not tangents. They don't touch the circle at all. Okay, so tangent touches the circle once. By letting the equation of the tangent be y equals mx plus 10, well, we knew that already. It's kind of them to tell us that that's plus 10, because of course it's plus 10. There's the 10. Find the 2 possible values of m. Now, we already have our starting point. Tangent, line, these intersect only once, which means if we were to try and find the point or points of intersection of these 2 equations, then we'd expect just the one solution. Hopefully planted enough seeds. If we try solve where these 2 graphs or these 2 functions, not functions, the circle's clearly not a function, sorry, there's 2 relations, the one is a function, are equal where they intersect, we're expecting one solution. So y we know is mx plus 10, and when we solve this, we're expecting one solution. There'll be 2 values of m to give that one solution. In other words, wait a second, we're going to get a whole lot of stuff here. I can see that there's going to be an x squared. In other words, I can see some sort of quadratic coming along, right? So we got our quadratic and we rearrange it. So quadratic equals 0. And if we were to solve that using the quadratic formula, of course, the thing that's interesting in the quadratic formula is the discriminant. Now, we already said there's only one solution. So therefore, we know we can make a statement about our discriminant, and therefore we can work out what our values of m are, and they're clearly going to be 2, and they're related to each other because of this lovely symmetry going on. Okay, so there's some ideas without all the algebra detail. I can fill that in easily, right?